It's December the 10th, 2020, and welcome to the Water Action Platform. Last month, we had a focus on the circular economy, and this month, it's non-revenue water. As always, I thank our sponsors, and I'm pleased to share that we have a new sponsor, Tecta PDS. Thank you for your support. Now, before we get into our non-revenue water theme, let's start with three short updates on COVID-19. The vaccines may be here now, but we are still a long way from the end of this pandemic. The first COVID-19 update is this rather intriguing story about a method for calculating your COVID-19 risk. The approach is based on peer-reviewed scientific articles and introduces a completely new concept called the MicroCOVID. Quite simply, the risk of an activity is measured in microCOVIDs. One microCOVID represents a 1 in a million chance of catching COVID-19. Thus, an activity that's 20,000 microCOVIDs is very unsafe, since you have a 2% risk of getting COVID-19 every time you do it. Conversely, a 20 microCOVID activity is relatively safe, as you could do it every week for a year and still have only about a 0.1% chance of catching COVID-19. Now, the creators of this index decided that an annual risk budget of 1% chance of catching COVID-19 per year was reasonable for most healthy people, i.e. people who are neither vulnerable themselves or in regular contact with vulnerable people. A 1% risk per year approach would mean weekly activities must add up to less than 200 microCOVIDs, and you can calculate your risk activities by following the links presented here. Now, this approach is a truly fascinating way of understanding and managing our COVID-19 exposure risk. I deliberately opened by describing this approach as intriguing, because I am sure it will stimulate much debate over the coming months. Now, our second COVID story today looks at the presence of SARS-CoV-2 in water and wastewater. As we've reported before, the stool and used masks from COVID-19 carriers are considered as the primary route of transmission into wastewater. Most coronaviruses which infect humans are inactivated rapidly in water, but the RNA of SARS-CoV-2 has been widely detected in untreated wastewaters and offers a method of early outbreak detection. However, Randazzo et al. And Fimoldi et al. In two different studies have reported that the SARS-CoV-2 RNA was not detected in tertiary effluent samples where the disinfection process adopted was NaClO, or the combination of LaClO and UV, or peracetic acid, or high-intensity UV lamps. Now, a further thought to perhaps keep in mind is that SARS-CoV-2 virions are of a size range of 60 to 140 nanometers in diameter. Now, this means that ultrafiltration, nanofiltration and reverse osmosis membranes will all reject them. Now, this might mean that we should start thinking about doing disinfection on the reject waters from high-risk wastewater treatment plants, i.e. those serving hospitals. Our last COVID-19 update today looks at what we know about the late-stage vaccine candidates. Now, as has been reported widely in the media, currently there are only 3 vaccines that have published preliminary data from phase 3 trials. The Oxford AstraZeneca vaccine, the Pfizer BioNTech vaccine, and the US Moderna vaccine. Now, the Oxford AstraZeneca vaccine has been tested across the world with trials in the UK, Brazil, South Africa, and the United States. Phase 2 results published in The Lancet showed that the vaccine produced a similar immune response in both old and young participants. The Phase 3 interim results, which were based on 131 cases, suggested the vaccine was 90% effective when a half dose was given, followed by a full dose a month later. Now, the Oxford team has stressed that they want their vaccine to be accessible all around the world, not just in high-income countries. As such, large-scale manufacturing has been set up in over 10 countries, and the team expects the vaccine to be available at a low price, about $4 per dose. Notably also, this vaccine can be stored at fridge temperatures. Moving on to the Pfizer vaccine, well, this was the first vaccine candidate to be submitted to the US Food and Drug Administration for emergency use authorization. The submission was filed on the 20th of November after the conclusion of the phase 3 trial. Now, the results evaluated 170 confirmed cases and reported that the vaccine was 95% effective 28 days after the first dose. Now, this vaccine, however, is estimated to cost at around $18 per dose, much higher than the Oxford-AstraZeneca vaccine. And concerns have also been raised over the logistics, as this vaccine has to be stored at -70 degrees C. Moving now to the third vaccine from Moderna. This is reported as 94.5% effective. This analysis was based on 95 COVID-19 cases, of which 90 were observed in the placebo group and 5 were reported from the vaccine group. This trial enrolled more than 30,000 US participants, including 7,000 aged over 65 and 5,000 under 65, but with high risk of chronic diseases. And more than one-third, 37% or 11,000 people, were from communities of colour. Of the 95 COVID-19 cases, 15 were adults over 65 and 20 identified as being from diverse communities. When it comes to storage, the Moderna vaccine can be stored in a household fridge for 30 days, or even at room temperature for up to 12 hours. However, compared with the Oxford, AstraZeneca and Pfizer vaccines, Moderna's candidate is much more expensive at approximately $30 per dose. So what's the takeaway from all this? Well, it is that we now have some credible options, and over the coming months, those options will hopefully just increase. So we now come to our section on non-revenue water, and we chose this theme following feedback and requests from some of our members. Over the next few minutes, we're going to hear about 3 different disruptive technologies and an overview of a recent international leakage benchmarking study. However, before we get to those, let's have a quick look at the results from the 3-question survey that we sent out a few days ago. We've had over 100 responses from all around the globe. Question 1 was, do you have a leakage management strategy? Reassuringly, 47% of the utilities who responded said yes. Not only do they have a strategy, but it is a fully developed and board-owned strategy. That said, 13% stated that they didn't have any leakage management strategy, and that was much higher than I personally had expected. The second question was, what technologies have you adopted? Handheld digital technology came out highest, above permanently installed real-time solutions, which itself was above pressure management systems. Interestingly, there was a decent slug of responses, in green on this graph, who said that leakage management strategy was not reliant on any technology. The third question, however, delved a little deeper, asking which of the technologies adopted were actually the most useful. Here, the results get significantly more interesting, with the clear winner being the permanently installed real-time technologies. Handheld digital devices, which were the most widely adopted in the previous question, actually came in just behind pressure management. Now, this is obviously a relatively simple one-off survey, but it does provide some thought-provoking questions. And furthermore, it provides a great introduction to our next speaker, Paul Harris. Paul recently completed an international benchmarking study, leakage benchmarking study, which involved 16 utilities from Australia, Brazil and Northern Europe. Perhaps cruelly, I set him the task of sharing in just 3 minutes what they did, who they did it for, and what they learned. Paul, over to you.
Thank you, Piers. What is our leakage management benchmarking program? Well, it's 4 things. It's a comparison of your performance to the IWA's non-revenue water balance and providing you with improvements. It's a comparison of your performance to the 4 leakage management pillars and providing you with performance improvements. We provide you with an industry-leading practices compendium of 36 great practices. We also give you access to an industry best practice workshop, which provides you with great knowledge and networking opportunities with like-minded people. Who's in the program? Well, we were lucky to have 16 great participants, 7 of those from the UK that included Thames Water, United Utilities and Severn Trent. 8 from Australia that included Sydney Water, Unity Water, City West Water, and a business from Brazil, AGEA. What were the key program learnings? Well, across the non-revenue water balance, there were a number of key findings, definitely varying levels of confidence in the being non-revenue water calculation. Most Australians using IWA assumptions, while the UK were doing quite a lot of bottom-up calculations to actually meet Ofwat regulatory reporting requirements. Certainly varying levels of confidence in apportioning real losses across asset classes, and a lot of common challenges around measuring losses in real time, with a key issue being the difficulty and cost of monitoring particular networks. With relation to the first leakage management pillar, pressure management, the UK businesses are really doing a great job in this space. They've been doing it for 10 to 15 years, much higher levels of investment than the Australian contingent, and with that, significantly higher density of PRVs and DMAs. Whilst there's a lot of fixed outlet PRVs throughout the world, the UK are really stepping this up with a movement to advanced control and certainly more sophisticated pressure modulation. In relation to the second leakage management pillar, active leakage control, the Australian utilities are using customers quite a bit to report leaks through strong engagement processes, whilst the UK doing a lot of work around proactive leakage detection teams and using active leakage detection technologies, which has been mirrored in their investment into acoustic sensors and other systems to provide constant measurement and monitoring of leaks. The third leakage management pillar, speed and quality of repairs. Well, the Australians are highly regulated in this space and done a lot of work reducing bursts and leaks on the back of lots of recent drought conditions and pressure from the community. In the UK, we found that quite a number of the businesses are really hamstrung in terms of the fact that they've got a lot of bureaucratic challenges of being able to access third-party assets and certainly work through third parties to access different assets. And in relation to the final leakage management pillar, asset management, as you'd expect, the Australians had much younger networks with much lower proportions of cast iron than the UK. Significant gaps are observed in relation to service connection assets throughout the entire world, with participants really lacking information around age and material. And the Australians actually spend quite a lot more money on asset management than the UK, particularly around water main renewals. Thank you.
Thank you, Paul. That was a staggeringly informative 3 minutes. If you want more information, let me know and I'll connect you with Paul directly. I should also state that last Friday was World Water Loss Day, which has been a global initiative organised by the IWA Water Loss Specialist Group. There is a short interview with Stuart Hamilton, one of the key brains behind this initiative, on the Water Action Platform website. The link is here. We now come to our technology showcase section, and this week we have 3 different leakage management technologies. The following technologies have all been identified through the long-running technology approval group forums, which I'm not going to discuss here. The first is Kamstrup's FlowIQ 2200, an ultrasonic domestic water meter that includes a built-in acoustic leak detection system. It can be used to identify leaks in customer properties, service pipes, and, in some cases, connecting mains. The inventive step here is when the Kamstrup team realised that an ultrasonic meter is basically an acoustic instrument that's been tuned to a certain frequency band. Thus, with some modifications, they can become noise loggers. Here is Sune Dupont, a development engineer from Kamstrup, sharing some more details.
So what we have done is that we, in the FlowIQ 2200, we have introduced an acoustic sensor, and doing that we obtain sensors installed throughout the grid. We have our sensors coupled directly to the water pipe, since it's a part of the pipes. You get a low maintenance, and you can use the existing radio network set up by the meters. Of course, there are some challenges doing this. You need a very low power consumption of your sensor, because you still want to have a water meter that can last for 16 years. And of course, the cost of each sensor must be relatively low compared to what the price or the cost is of a standard water meter. The really interesting part is, what is the lowest noise level seen at the meter? Because if the lowest noise level is increased, this could be due to a leak nearby. So we have introduced an algorithm in the meter that looks for this lowest noise level, and afterward it presents it over radio to a central system. Here you have a screen dump from our online analysis platform called Leak Detector. In the central part you see a map with some dots. A red dot means that you have a meter with a high noise level, and a blue dot is a meter with a lower noise level. So here, the only one interesting is the red one, and if I mark it, in the right-hand side, we'll get a graph. So this is the noise pattern from that particular meter. I can tell you that the meter was actually installed in the middle of September, and you can see just after the meter was installed, the noise at the meter rose to a level about 150. So if I show you just a little video here, this is here you have the service line coming in, and you have the plumbing, and here's the meter and the consumer. The consumer is on this side, and down here you have the leak. So it's actually before the meter, which is the interesting part, right? Because after the meter, that's trivial. If you look at this was actually the problem. You have the polyethylene pipe service line coming in, and you have the iron pipe here, and this coupling was damaged and was generating a leak around 500 liters per hour. So if you go into leak detector and look at the graph now, after the leak was fixed, the noise got low just as expected, and everyone was happy.
Now, as far as we know, this is the first smart meter on the market to detect leaks, both on the customer side using non-zero flow detection and upstream of the meter based on acoustic noise detection. Other smart meters only detect leaks on the customer side. Now, after introducing the FlowIQ into the European market in 2019, more than 200,000 meters have been installed and more than 500 leaks have been found in Denmark, Sweden, Norway, Germany, France and the United States, which feels pretty good going in anyone's book. Our second technology is SmartValve, which I think is a truly beautiful technology. Simple in concept, yet addresses a really important problem: the inefficient or incorrect operation of valves, which often leads to leaks, bursts and discoloration events caused by fluctuating pressure. SmartValve is a mobile app that monitors, schedules and manages manual valve operations across a water network. It was developed to help avoid the generation of transients and tracks valve status. It can be updated on internal systems, GIS and CMMS. Here is Andrew Talks, Director and Founder of SmartValve, to share some more.
So SmartValve is a cross-platform app, and it helps you schedule and monitor all of your manual valve operations. The mobile phone connects to any valve key with a simple quad lock system, and it attaches to the valve key either on the top of the shaft or on the down shaft. And it records the speed, the number of turns, the direction of the turn, the valve location, the time, the operator, and lots of other data behind the scenes as well. So you can see on the app now, it's telling them here how to actually turn the valve, and the screen's green at the moment because he's not moved it, so there's no error. But we're going to start turning this valve. And as Nick turns the valve, we're on the first part of this turn profile, which is relatively quick. We're closing it down, so that first 80% of the turn is quite quick. We're going to get to the designated number of turns that this valve needs on the first part of the operation, and it will tell him to stop, which it's just done. And now it's talking Nick through the second part of this operation, saying, right, now you've closed most of the valve, now this last 20% should be really going much slower and turning it down. But what we're actually doing here is just proving that a transient's going to occur. So Nick's going to ignore what SmartValve tells him, and he's going to spin it down as quick as he can, and it's flashing red and it's beeping at him. And you can certainly see that through that ineffective valve operation, that transient has been occurred. So it's giving the technician real-time feedback on how they're turning the valve out in the field. And all of those turn profiles can be set and pre-designed within SmartValve. So this shows a close operation on a 4-inch sluice valve, and this was early on. And this is the data that SmartValve is recording in its ad hoc mode. So here it's telling us the revolutions per minute, and here it's showing us the number of turns. But you can see there's not a lot of profile going on within that particular turn, and this is how the technician was turning valves out in the field. We gave them SmartValve, and we gave them a planned turn. So it said, right, for this first 80% of the turn, you're not going to go any faster than 40, and for the last 20%, you're not going to go any faster than 5 revolutions per minute. And you can see when they did that with SmartValve telling them how to operate and the visual keys and turns, it's showing a huge change in behaviors here. And we know that at that profile, no transient was caused in the turning of that valve. So then we took it away and said, right, now go and turn on an ad hoc profile again following that. And we can see they match the profile in a much better way. So we've shown that we can actually change behaviours on a really small, discrete trial. And obviously the advantages here are, very obvious. We're looking to reduce the number of leaks and bursts that are caused by ineffective valve operations.
Isn't that wonderful? The bit I love about that is how the operator behaviour was changed. Using this gloriously simple technology, well, at least simple in concept, the brains behind it, I'm sure, are very complex. A stark and hopefully sustainable improvement in network management can be achieved. SmartValve was developed and tested in cooperation with UK water companies, several of which have deployed and trialled the system to date. More trials are planned or underway in France, Australia and New Zealand. Our third and final technology showcase is FIDO, a sensor-agnostic approach to leak detection. As you'll see from the following video, FIDO is a multi-purpose leak detection device. It can be used as a listening stick, a mobile acoustic logger, or a free-flowing and in-pipe tool. Here is Chief Executive Victoria Edwards to share some more.
Welcome to FIDO. Water leak detection to 1 metre, accurately, safely, efficiently. Now we all know the damage of non-revenue water, environmental, financial, commercial, reputational. And we're all chasing the same thing, but doesn't it sometimes feel as if we're in the midst of this? Wacky races. There's some great technology out there. You've got acoustic loggers, hydrophones, satellites, you've got big data analytics, you've also got your old-fashioned listening stick, your sniffer dogs. It's all proprietary technology, it's all disparate and disjointed. So FIDO has taken a holistic approach to leak detection. We think there's a better way. It's a simple 3-step process that is sensor and platform agnostic, underpinned by our FIDO AI platform. First thing we need to do, we need to generate a point of interest. So FIDO AI will analyse any audio or kinetic file and instantly give you not only leak, no leak, but also that leak size. So there's no longer putting an engineer in a van until FIDO has told you there's a leak and what size that leak is. So then you need to go and generate those points of evidence in the field to mark that blue bar. And you do that by taking the FIDO AI in the engineer's back pocket. Simple, rugged puck device. They just shake to wake. They don't have to put any technical input data at all. But it also works with your existing kit, such as your correlators, helping find those noises on plastic pipes. And you use the FIDO puck in a listening stick mode, or as a top sounder, or as an overnight sampler. And via the FIDO app, the technician gets the results of leak, no leak, all the evidence they need, the location and the size, working with your kit and the FIDO kit, mark that blue bar. Third point in the process, you need proof that the leak has been resolved and repaired. So you give this FIDO to your dig gang, they go out. What happens if it's a dry dig? Well, you don't abort anymore. You put one FIDO on one end of the pipe, FIDO on the other end, and it will tell you the direction of the leak to carry on digging. It then tells you when the leak's been repaired, so you can quantify your leak sizing for all your management information or every regulatory reporting on driving down those leakage targets. So as we can see here, FIDO is, as we said, we are platform and sensor agnostic. So you can see FIDO at the heart here, our AI platform. And we pull in all sorts of data, DMA data, night flow data, dig data, acoustic logger data, hydrophone data, and we analyze it and push it back out either to through an API to your own systems, or delivering the results direct to the technicians in the field to find the leak first time, find the largest leaks first, make sure they've been repaired properly. Thank you for your time. Thank you for visiting FIDO, a sensor agnostic, holistic approach to accurate leak detection.
Thanks, Victoria. FIDO has a 5-year framework agreement with United Utilities and 3 more UK deployments in the works. It has also been deployed in an Australian city and trialled in South Africa. If you want to know more, we have a pre-recorded interview with Victoria on the Water Action Platform website. As always, if you want to know more about any of these technologies, just let me know. With the winter season fully in swing in the Northern Hemisphere and all our Christmas holidays almost upon us, our And Finally Today looks at the evidence around winterizing your mask and addressing the question, do I really need to wear a mask outside in the cold? Now, as we all hopefully know, observing proper social distancing while outside is a really protective approach. We have, however, seen documented cases of outdoor transmission when people mix at barbecues and sports events. With this in mind, the advice is that if you're going out in and out of stores or getting on and off public transport while doing errands, it is best just to keep your mask on all the time. This begs the question, of course, as to whether a scarf is a good mask. And the answer, I'm afraid, is an emphatic no. Medical experts state that there is too much variation in scarves and neck gaiters for them to be used as masks. Stitching can be too loose and the material is often too thin. The medical advice appears to be to wear a mask and a scarf when outside, as this will at least stop the mask from freezing. So, with all the issue of masks, is it best just to stay indoors this winter? Well, the resounding answer from the medics is also a no. On the contrary, do as much of your seasonal socialising outdoors as you can, especially of eating and drinking and singing. Enjoy your Christmas to the full, just enjoy it outside if you can. Now, just before we finish, here is an event I mentioned last time. It is a virtual 3D tour of Agea's new wastewater treatment facility in Brazil, including their digital twin. This tour is on December the 15th, and since I mentioned it on last month's broadcast, over 200 people have registered. If you also want to join, then just drop me an email. Interestingly enough, other organisations have offered similar sort of key topic virtual tours, so we may see some more of these events in 2021. So that brings this week's broadcast to a close. I hope you enjoyed the focus on non-revenue water. In January, the theme will be emerging pollutants, including PFAS. However, before we get to January's webinar, we have a special extra one scheduled for next week. On Thursday, the 17th of December, we will have a Christmas special in which we will share some stories relating to some of the aid agencies over the past year. I hope you can join us. We also have our special 12 Days of Christmas Advent calendar on social media, which highlights 12 of the key learnings which have come out of the Water Action platform over the past year. If you've not yet signed up, follow the links on social media. Each highlight is only a minute long, but at the end there is a very special surprise. It's a few seconds of pure Christmassy happiness. It will uplift your soul and get you ready for the holiday season. Keep asking questions, keep sharing, and keep safe.